Alright, so as you can see, we're back to our old graph again, but this time we're going to be playing a little bit with the tangent function, and I think this is going to be a slightly shorter video because I'm going to be plotting a little bit less, and it's we're getting used to this process now, so it should be a bit easier. So, now we have, what's our function? Our function of x, I'm going to be using green again, or actually, yeah, let's use green. Green is very vibrant. We're going to say that that's equal to the tangent of x this time. Oh no. And you're going to have to take my word on this one a little bit more, because I don't really want to spend the time using a calculator to find tangents. And there are only a couple that you really know by heart. Not a lot less, if any less, than cosine or sine. But it'll be much easier this way. So let's start at 0 as always. What is the tangent of 0? Well, tangent, as you know, is the opposite over adjacent, right? It's the ratio of the far side to the near side. So, what's the tangent of 0? If we have our, if we shoot out this little radius here, and we take, that's 0 degrees from the x-axis, basically, essentially, we're taking this far side here, which is just 0. So the tangent of 0 is going to be equal to 0 over 1, which is equal to 0. So that's quite nice, I think. It's kind of satisfying. Now, what about another one? Pi over 4. Pi over 4, and you should be used to this by now. Pi over 4. Well, as we've seen in the past, this is an isosceles triangle, so the opposite side is equal to the adjacent side. So we're going to have a tan ratio of 1. So this is going to be equal to 1. Alright, and let's start marking these. I'm going to mark 1 a little bit lower down this time, which is kind of interesting. Maybe even lower than that, actually. We have 1 and negative 1. Because this graph is, let's say, not quite as bounded as the last ones were. So, at pi over 4, we have a tangent of 1. What about pi over 2? Right? Let's just go with the usual ones. These ones we're pretty familiar with. So what is the tangent of pi over 2? Uh-oh. Now, tangent, as you probably remember, is the same as sine over cosine, because of how it's a ratio, and you take, well, you probably know this from the unit circle videos, but it doesn't help to review a little bit, right? Because we have a right triangle here, and the tangent is the same as the opposite side over the adjacent side. And how do you find the opposite side? Well, so this is, let's say, B, C, and A, like we usually do. And the sign of this is B divided by C, right? It's a ratio of B to C. So you multiply, oh dear, just wait a moment. So you multiply that ratio, so the sine of theta, right, is equal to B over C. So if you multiply that times C, you get B. So if we multiply, both sides, this is pretty simple algebra. So if we have C sine of that angle, that's going to be B. So that's our far side. So C sine of theta is equal to B. So we want to know B over A. And that's going to be the same as C sine of theta. And then we have the same thing. I'm not going to review too much for this one, but it's cosine, right? It's the ratio of the adjacent to the hypotenuse, right? So we're going to have C cosine. So we're going to have C sine over C cosine. And the C's will just cancel out, so we have tangent of some angle is equal to sine over cosine. And this just might make it easier because what is the sine of pi over 2? Well, the sine of pi over 2 is 1, but the cosine of pi over 2 is 0. So if we take 1 divided by 0, that's getting pretty large. That's undefined. So essentially, that's getting to infinity the closer we get to it. So if we have 1 over something really tiny, we're essentially getting a really huge number because we're dividing by a really tiny one. So as we get to pi over 2, our numbers are going to get huge, right? So because as we get to pi over 2, that's going to be we can think of that as not really infinity because it's undefined, but it approaches infinity, right? Because as the cosine is below here, so as the cosine is, getting smaller, as we get closer to pi over 2, it is getting smaller, then this whole thing will get larger. So we're going to have something like this. Oh dear, let's do this right. Oh dear. Yeah. Oh, and look, it's gone off the screen and shot right through our function symbol. Now if we go backwards, we're going to have pi over 4 back here. And we can do it just like this. So the sine of negative pi over 4 over the cosine of negative pi over 4. And if, as you recall, going negative just means going clockwise. So what's the sine of this? It's going to be the same as sine of pi over 4, but it's going to be negative. So it's going to be, like negative square root of 2 over 2, as we saw in previous videos. This isn't, too important in that we're just solving this thing. I'm just kind of throwing things at you right here over the cosine, which is going to be the same. So that's actually going to turn out being negative 1, because we're going to have a negative 1 thing over the cosine, which is the same thing, but it's not negative. I'm just going to tell you right now that the tangent of negative pi over 2, which would be up here, pi over 4 is going to be equal to negative 1. So, we get a similar pattern like we've done in the past. But this time, where it's going on both angles, and as we get to negative pi over 2, that's basically the same. It's still going to be oh my gosh, I can't write a 2 or a 4 when I need them. It's essentially the same, because now we have 90 degrees down here, and our sine is going to be negative because we're below the x-axis, but our cosine is still 0, and we're still dividing by 0, and that's kind of a big problem. So we're going to get a very similar pattern over here. But what happens once we go past pi over 2? And this is actually going to create what's called an asymptote. If you're not familiar with what an asymptote is, I'm going to erase a bunch of this junk over here just to clean up a little bit. An asymptote basically represents kind of what the function of kind of what the slope of a function approaches. If you're familiar with calculus, basically you'll see this is getting steeper and steeper until eventually it's just going straight up. That's the idea. You're just getting to infinity. You're getting this 1 over 0. This is just like, this is just undefined. All right? So, now what do we have? And we'll have a similar thing here. Again, I'll make a video about asymptotes so that this becomes more clearly. But this is basically kind of, this shows, think of it this way, this shows that the function is going up to infinity. And now, what if we go past pi over 2? What if we go, like, 3 pi over 4? And then back to pi. Let's plug those in. So 3 pi over 4. It's going to be equal to the sine of that angle over the cosine of that angle. So the sine of that angle was the square root of 2 over 2, as I recall. And the cosine of that angle was, what was it? It was the negative square root of 2 over 2. And you can review the last videos, but this is going to turn out being negative 1. All right, so now it's negative after here. So what happens? Let's think of it just a tiny bit past pi over 2. So as we showed, because tangent is equal to sine of theta over cosine of theta, because just knowing this negative 1 here doesn't really help us. So when this got to cosine of pi over 2, it got basically increasingly low until it got to 0, at which point we're dividing by 0. But if cosine is a little bit greater, like if we go a little bit past pi over 2, these cosines are still small, but they're negative, right? I mean, they're... No. Well, yeah. So we're going to be dividing by really small numbers, which is going to make this huge, but they're going to be negative. So we're going to get a similar pattern where we're going down to infinity down here. Right? We're basically going down to negative infinity. And then as we get to pi, the sine of pi over the cosine of pi, which is 0 over 1, is just going to be equal to 0. And we're going to have a similar pattern. So we're going to have a repeating function like this, but it has all these crazy asymptotes and things. It jumps off to infinity all the time. If you want to graph tangent and gaze at its amazement, you can. It's kind of a fun function, how it contains asymptotes and it's repeating like this. But it's definitely it definitely doesn't look like the sine or cosine functions. All right then. That's what the tangent function looks like. In the next video, I think we're going to be talking about waves themselves and delve back into the world of sines and cosines and not quite the crazy tangents. All right, thanks for watching.